So today we're going to be doing all of the kind of the sine and the cosine law together, but in problem scenarios. We are going to go right to the next page, down, actually to right here. I want you to kind of draw a little line under the C, because there's one thing that I do want to just talk about, and that is the parallel lines theorem. Okay, the parallel lines theorem. Okay, because it comes in handy whenever you're using directions. Okay, so what is the parallel lines theorem? Well, first of all, if you're going to have a theorem about parallel lines, let's draw two parallel lines. Now, parallel lines are like railroad tracks, right? They run right beside each other, except railroad tracks do curve, and the definition of a line is it's straight. So you have to be a little bit flexible with that, but the gist of it is these lines always have to be the same distance away from each other. They will never intersect, ever, okay? True parallel lines will never intersect. And you can see how railroad tracks, it'd be kind of devastating for the train if they ever do intersect, okay? So they have to make sure they're always the same distance apart the whole time. Now, the parallel lines theorem is not just that we got two lines parallel. We have this thing, if it cuts it, it's called a transversal, okay? And hopefully you've done this in junior high, but when so this should be review. Whenever you cut two parallel lines with a transversal, these things happen. Now, first of all, this angle is equal to this angle, okay? Now, this angle here would equal this angle. That's supposed to be a y, okay? Now, x and y do not equal each other, do they? Okay? If that transversal cut it totally at 90 degrees, yes, then x and y would equal each other. That's the only time. Does everybody remember this? It's kind of like if you took the two lines and you brought them together and they fell right on top of each other. Do you see how the x would fall on top of the x and the y would fall on top of the y? So if you just squish those together, the x would be on top of the x. Now, there's also called the opposite angles theorem. And the opposite angles theorem say that these two should be the same. Okay, and they always are. Whenever you have two lines that intersect, these are always the same. Okay, and those are always the same. So x is equal to x, and then y is equal to y, right? Because they're opposite each other. And because of so we could even go to the other one, and we know that these two must be that, right? But the same thing happens. If you took those two lines and you squished them on top of each other, see what would fall on top of each other? The x's and the y's. And there's one other thing that you can tell me. What is x plus y? 180. No matter where you take the x, no matter where you take the y from. So you could take this x over here, say, and add it to that y over there, and I guarantee it'll equal 180. Okay, it doesn't matter. But the parallel lines theorem comes in handy when we're talking about the compass and direction, all that stuff, which we will talk about. Okay? Now, the first thing I'm going to teach you is how to use bearings. Now, have you guys done this in physics yet? Yeah? Okay? So, I might teach it a little different, but since you know it, hopefully I don't unlearn you. The way that I think about it is, okay, bearing is true north, okay? And for those people that don't know how to use a compass, there's a magnetic field that runs along the Earth, and it runs north-south. If you have a compass, the needle always points north. Okay, so you get your little compass, the needle will always point north. So what you do, see a heavy little N there? So you actually turn until the north lines up the arrow, like the little N on the compass, right? And now you know where east, ever eat soggy wieners, right? So that's how you get your direction, and then you're walking through the forest and you can find stuff, okay? And that's what I think of, because there's two types of directions. I'll teach the other one later. But this one's called the bearing, and the way that I think of bearings is, okay, there's bears. Bears are in the woods, and if I was in the woods, I'd use a compass. Okay? Get it? Think of the bear. Woods, trees, compass. Okay? You got it all? It's in there? Okay? Now, it does everything from north. It's very much like a clock, where 12 o'clock is north. It does go clockwise, and it always goes to north. There's no negative directions. It's just north. So if it would say, if it's at 10 degrees, a bearing of 10 degrees, I go to north, and then I'm just going to turn 10 degrees, and I'm going to go that way. I'm going to turn 10 degrees clockwise. Now, what would 1 degree counterclockwise be? Well, it would be a bearing of 359, right? You only give positive clockwise. So, do you see how, if you look at this, this is a bearing of 60. I'm going to do this in red. Bearing of 60, bearing of 240, bearing of 340. It does everything from north. Okay? So bearing, bears, woods, compass, and then you always go clockwise from north. Now remember, all of our directions have been coming from like 3 o'clock and going counterclockwise. So it's a little different now, but, and anybody that's ever done like orienteering, like you use your compass, you get to spot, and it tells tells you another direction, right? And then you go find that. You got to use a compass. Okay? Let's do a couple problems using the compass so we can try to get a picture. Okay? Now, we got a liner leaves the port 15 kilometers at 37 degrees to position Q, where it changes course to 270, and then 12 kilometers to position R. Complete the sketch to illustrate this information and calculate the distance and course the liner must sail to return back home. Okay? So, because this diagram, there's going to be a lot of stuff in it, what I'm going to do is I'm just going to blow this up here and then do the diagram. Okay? So, we are starting at where? P. And then I'm going to sail 37 degrees. Now, at every point, you do your little crosshairs, okay? And that's why I've blown up so that's north, east, south, west. Never eat soggy wieners, okay? So it says sail 37 degrees. Now, this has already been drawn for us, but we got to make sense of it. So this is 37 degrees, okay? And it says that I went 15 kilometers. And then I get to Q. There I am. Okay, so I'm there. So if you want, you can draw yourself a little arrow. Hey, this is the way I went. Okay. Now at Q, so you're like sailing and you get to point Q. It's this little island. Okay. And then at Q, they say, the Q island, they say, hey, now you have to go 270 degrees, a course of 270, 12 kilometers. So you have to go and draw this thing again. Now remember, you got north, so you're going to go 90, 180, 270 degrees, which is that, right? And you're going to sail for 12 kilometers. And then you're going to get over here. The question now asks, how far are you to get back home, back to P, and in what direction would you sail? Now, the reason why the notes are going to take a little bit longer today is because we are going to think about it. I should apologize for that in advance. But I do want people to think. I need to solve, if we do look at our little thing, I need to solve for Q. And I need angle R. So this is what I need. I need Q and angle R. And I'm just going to put a big R there because that's what that means, right? We know that capital letters mean angles and triangles. Okay, so it's kind of nice to know what we need. Or you go grocery shopping, you should make a list. Or you will forget something. So, I don't have any angles to do sine. Isaiah, what would you do? Okay. I'm gonna do this because you're close, okay? But I need everybody to see that these are parallel lines. Okay, does everybody see that? And you see that this angle here would be this angle here. Okay, so this is, just this is 37 degrees. Now, could you find that other angle? Huh? How? What is it? So you go 90 minus 37, which is, this would be 53 degrees. Now, the first class did not do it this way at all. They did it another way. They did not use the parallel lines theorem. Okay, they did this. They took this, and that's a 90 degree, right? And you see they have the 90 and the 37. They just did a 90 degree triangle here and found the 53. See, that would work too? Okay, so there's sometimes more than one way. Anyway, with 53, guess what I've got? Everyone see that? I have the coleslaw, right? Used my fork. So I'm finding angle Q. Angle Q, side Q, I mean. So we got Q equals square root of 12 squared plus 15 squared minus 2 times 12 times 15 times cos 53. Okay? And I'm going to assume at this point you guys know how to put this stuff in your calculator, so I'm just going to give you the answers. 12.34 dot 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 dot. Okay, that means don't really round it until the end. Okay, so this is 12.34 dot 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 dot. So I have now found that side. The second part of it is I need to find a angle R, right? How would I do that? Sine law, yeah. I can use the sine law because I have this loop and I have one of these. So that would be sine R over 15 equals sine 53 over that 12.34 dot dot dot. Now remember, you're going to use second sine and do all that. And just for sake of speed, we get an angle of 76 degrees. Okay. Now, this one will break your heart when you get this one back if you stop here, because you've done a lot of work. If it was multiple choice, I would say, you got to go 12.34 kilometers at a bearing of 76. Now, is it a bearing of 76? Because remember, we found this, right? We just found this is 76. Just did that. Is that the bearing? Does bearing come from the east? It comes from the north, right? So you're going to have to add 90 to it, right? To get the true bearing. So at a bearing of 90 plus is 166 degrees. Okay? Now, you guys are so inundated with this math lately, but you can't even comprehend how much knowledge it takes to do this question. Okay? Now, practice with these will make them better. Now, the thing that I love about this book that I hated about when I took math was the teacher would do like 4 or 5 examples, and I'm like, hey, those are easy. And then you got to the work, and they were 10 times harder than the examples, right? With this book, the examples are just as hard or harder than the work, right? So these examples are tough, but they include everything you need to know, and they get us thinking. So hopefully when you get to the homework, you're going, okay. And I do give you all the answers for the homework, so at least you have that assisting you as you're going through it. Okay? Because these are sweet to have the answers with. They're word problems. I mean, they're going to have the diagram done. So at least you could kind of like, what would you have done, right? Okay, next one. These are always everybody's favorite, right? We have 2 things leaving an airport, or 2 trains leave at the same time, and, well, it's trig this time, so I'm just going to get us back to normal here. Okay. So we do have 2 aircraft, A and B, leave an airport at the same time. A flies a course of 9 degrees at 700 kilometers an hour, and B flies 290 degrees at 600 kilometers an hour. Calculate the distance apart after 12 minutes. Okay? Now, first of all, before you get going on diagrams and stuff, find out how far they've gone. Okay? So let's talk about A. So A is going at 700 kilometers per hour. Now, how far would this plane go in 2 hours? 1,400. Now, that's the way I do stuff, so I can think about, well, what would I do if it's 12 minutes, okay? I should be multiplying still, because you multiplied by 2 to get 1,400. So, I actually always try to write it like that, because, I've done enough physics that I always like to see my units cancel, or I'm not very happy, okay? So I'm going to multiply by 2 hours if I was going to go, right, for 1,400. So I'm going to multiply by hours. So I have 12/60th of an hour. That's what 12 minutes is. See, and your H's are cancel, right? And you're left with kilometers. So you go 700 times 12/60, you get 140 kilometers, okay? Now B, same thing, 600 kilometers per hour times 12/60th, and you get 120 kilometers. Okay. So now we go to our, here's your airport, okay? That doesn't look like an airport because we're very far back. But if you zoomed in, it'd be an airport. Now, the first guy, A leaves an airport. He flies 90 degrees. Now, if you get a little, okay, he is flying, he or she is flying this way, and that is 140 kilometers, right? That's A is going that way. And then B is flying at 290, okay? So there's 270, so I'm going a little bit more, right? So that is like that. 120 kilometers, and that's B. And they just want to know how far apart they are. Now, the question that I would ask is, do we know the angle? Because we got to find this, guys. I don't know if you're getting that, but we need to find this. Yep. Yeah, I wouldn't say 100. Well, yeah, I got 140. I don't know. 700 times 12 over 60. Nope. Am I right? Wrong? I'm right? Okay. No worries, though. Thanks for asking, because I do make lots of mistakes. Okay. What's my angle there? 160, because there's 90. And if we kept going here, we need 60 more degrees. There's 60 degrees there. So that angle, 70 I mean, that angle is 160, okay? And then we could just use our coleslaw, right? We got the pitchfork. We're finding that. We know the two sides. It looks like kind of a mess there. Okay. So I'm going to just, I'll do it in black, my pitchfork here. There's my first one. And those are my two sides. Now, when your triangle opens up bigger and bigger, your fork looks a lot worse, right? But I still have the two sides of the enclosed angle, and that's how you use. If you know 3 out of 4 of your pitchfork or fork, you're going to do fine. Okay? So, again, you would use Q equals. Okay, well, let's do A equals. Let's call it A equals 120 squared plus 140 squared minus 2 times 120 times 140 times cos 160. Yep. Oh, yes. Thank you. And you'll get the distance A to equal 256 kilometers. Okay? Okay, now the next one, there is another way of doing it. And this way deals with, it says, oops, no, I don't like that one. Okay, this is the way that it is presented usually, south 55 east. Now, the way that I do these, to keep them really, really simple, is I split it into two things. So the first, it's kind of two steps. So when I read it, I do this first, and then I do this second box second. So if you look at south 55 east, what I do is it says south, so I look south. Here I am, up here, looking south. And then it says go 55 east. So then I just go 55 east. Okay? If it said south 55 west, I'd go 55 the other way. But I always do it from number 1. Okay? So here's an example. North, so I would go, there's north, and then 60 east. So there's 60 east. The other one, south, and then go 60 west. Okay, so my arrow goes that way. So it's crucial that you don't screw up east and west. Okay, so I do in every song leaders, put it down, and then I do it. Okay, this one is north, and then 20 west. Okay, this can also be called 20 west of north. So they do number 2 of 1. Okay, which is the same way to be able to do it. Okay, let's go and... Now, a ship observes a lighthouse direction 50 degrees west of north. So this is the same thing as north 50 west. Okay, so it's north and then go 50 degrees west of it. And then 15 degrees east of north, this is north 15 degrees east, right? So do your north, look in the north direction, and then go 15 east. Okay? Now this one's fun. Okay? So we're going to draw a nice big picture. So just kind of, we've got a ship observes a lighthouse in a direction, north 50, and after sailing 36 kilometers in a direction 35 west of south, so we didn't do that one, that would be south 35 west, okay? Of the lighthouse is observed in a direction 15 east of north. Now sketch the information, okay? So what we have is a ship sees a lighthouse over there. Does a little sailing, now sees a lighthouse over there. It wants to know how far is the lighthouse at the second observation. Okay? So this is all surveying stuff, right? And that's all this is. Okay? Well, first of all, let's draw our ship. Okay? Now, remember, I'm a trained professional, so don't compare your drawings to mine. You're young, innocent children who have not learned the ways. Now, there's your ship. The ship would be in water. Everyone with me so far? Water. No, not today. But if you want, you can make it. Story of Moses. Okay? Or Noah. Looks more like Noah's boat if I look at it now. So right now, he observes a lighthouse 50 degrees west of north. Okay, so at the lighthouse, we're going to draw, at the ship, we're going to draw your crosshairs, right? So you're standing on the ship, and you see the lighthouse 50 degrees west of north. Okay, so you go never eat soggy wieners. So 50 degrees would be, like I'm just going to draw this line here. And that would be like 50 degrees right there. Okay, 50 degrees west of north. Now, I sail 35 degrees west of south. West of south. So we go south first, then I'm going 35, okay? So I sail over there, and I do this. This is 35 degrees. And then I see, so this is position 1. And then now you're over here at position 2. You sailed 36 kilometers. Okay? And you see a lighthouse at, okay, so you gotta get this thing going if you see a lighthouse at 15 east of north. Never eat soggy wieners. So 15 degrees east of north would be something like this. So this is where your lighthouse would be. Okay? And this right here, we got to write this in. This is 15 degrees there. That's my drawing. The question asks, at position 2, how far am I from the lighthouse? So this is your unknown, or your x, right? Now it's really important everybody just has just a chance to look at this and figure out some sort of plan. Now remember, you have the sine law and you have the cosine law to deal with here. That's it. So if you know what you need, go looking for it. Now, is there anything I can just put in on this right now that can, it may help me, may not help me, I don't know. Which one? Yeah, I can do this because these three together should add up to 180, correct? Does that make sense? Here, these three together, 1, 2, 3, should add up to 180. It's a straight line. Okay? So what would this be? 95. Okay, so let's put that in. This is 95 degrees. Okay, now little things like if you don't know that all angles add up to 180, you're probably stuck at this point. Okay, so that's 95 degrees. Yep. How can I do that? You're good at that parallel line theorem. Okay, so what do I know then? Okay, so I just want everybody to see this for a sec. Just relax. Everybody calm down. Okay, so you see how these are supposed to be parallel lines. Okay, can you see that? They are supposed to be because they run north-south. Then we have a, okay, just watch, work with me here. We have a transversal that cuts, you see that? So this angle here, right here, should be this angle here. Yep. This entire thing. Okay? So let me just show you that now. And now if you go back to the page that I just talked about, there's my highlighter here, okay? So this angle here should equal that angle there. Those are nice big thick. Okay, so these two angles should be equal, okay? Now it's your parallel lines theorem. If you turn back to the other page, yes, those are always equal. So therefore, I can find this angle. So this would be 35 degrees, this whole thing. Therefore, what would this be then? 20 degrees, good. Because you take that 15 away. Okay? Now, do you see how we have an entire triangle, the 95 and the 20, Therefore, we can go find this angle here, right? Because all angles of a triangle add up to 180. So what is that angle? 65 degrees. Okay, so there's 2 times that your parallel lines theorem. Okay, Isaiah, why are you so good at the parallel lines theorem? Physics? So you don't know. It's just a gift. There you go. You found your gifting in math. Now, I haven't done any trig stuff. I've kind of done the parallel lines here, and I found some angles. How can I find x? Sine law, right? Okay. So we have this loop, and we have one of the 2 there. So then I would just go sine, oh no, I don't want sine, I want x over sine 95 equals 36 over sine 65. Okay, and you'll get x to equal 40 kilometers. That's weird, because we're done. Yeah. Well, I didn't do it upside down. I always put my unknown top left. So if you went sine 95 over x equals sine 65, you got work to do after, because you got to get, right? So just being proactive. Okay. Now, so you're doing 5 and then 7 to 16. Okay, I'm just going to go through this and then I'm